Today I'm going to visit the clouds. Wait, you don't have to go that far. They're right down here. Let's check it out. The cloud I'm talking about is the digital cloud, which isn't made of water, but of data. And we store almost everything in the cloud. It's photos, documents, phone backups. But it's more than just storing our stuff. To send a message, post on social media, or even watch this video here, you also use the cloud. You can't see or touch the internet. It's the link between computers, from small ones like cell phones to large ones like servers. They're the ones that store the data. We access it all the time on the internet, including this video. They're on 24 hours a day, 7 days a week, 365 days a year in buildings like this, which are called data centers. So, you can imagine the challenge it is to make all this work. I'm in Santana do Parnaíba near Sao Paulo, where several data centers are located. From Equinix, the world's largest digital infrastructure company, serving clients in technology, streaming, finance, gaming, e-commerce, and carriers. So, for sure, some of your connections pass through here every day.
Data centers are now part of everyone's life. Anyone using technology relies on a data center at all times. Picture an Equinix data center as a large airport. Passengers represent data and airplanes are the interconnections. This is Equinix's role worldwide, including Brazil. We build major airports worldwide to enable data and airplanes to travel and connect.
You can imagine the amount of important, sensitive, and secret information that passes through here. So, a data center has several layers of security. There are many password-protected doors that I have to go through to get there. Everything is monitored, controlled, and recorded. We have the privilege of getting to know a data center, how it works, because Equinix opened the doors of SP3 for us. But this is just one of their data centers in Sao Paulo. Basically, each client rents a space here, like a room in a commercial building. Clients can rent these entire spaces, which are called cages. But there are also shared cages where clients can rent only the shelves in here, called racks, not this here. So there are several computers stacked. Each of these is a server. Yes, when we hear about a server, it's a machine like this one. Each one of these can store websites, process information, run videos, or even have an entire company's system. I've always wanted to see a professional server, a really top server, up close and open it to see what it's like inside. They brought us a retired one to examine. Its drawer-like shape lets it slide into the rack. It's also easy to maintain because you take out one computer at a time. Here in the front are the hard drives, which store the information that's being shared. So it's easy for you to swap out a hard drive, for example, and replace it. Let's take a look inside. It kind of reminds you of the computer we have at home, but in a much more compact way, like a giant laptop. The power supply is here, the processors, memory, very powerful cooling, and the hard drives up front. One of the products that Equinix offers is called colocation. The customer leaves their machines here, and they guarantee three things: connectivity, climate control, and power. All this is provided 24/7 without fail, which is why everything is redundant. If the power goes out, there's already a second line from the utility company. If both fail, the generator kicks in. If an internet cable breaks, there's another connection ready.
Elevators are doubled, so if one fails, staff can still move equipment to upper floors. The elevators are large and can hold up to 2 tons.
Are even the Equinix employees redundant? Jokes aside, everything I'm saying makes sense. I need to explain what the internet is first. And for that, I'm going to use this video. When we talk about the internet, it feels like it's some kind of signal. You have internet there. Your computer has internet, but it's really a network of connected machines accessing distant information, for example. There's a video that I saved on this computer here. Okay, I'm going to play it. This is our test video. It will always be stored on computer A, on the hard drive of computer A. But after we connect the network, you can also access it from computer B. So, at this moment, Maybe you're already watching me on computer B, but the file is stored on A. It's going through the network cable to get here. Up to this point, everything's fine, right? But now let's make things a little more complicated. I'm going to write the name of the computer here and connect a second laptop, computer B, to the network cable. Now both are connected. And look how cool this is. I can access the video that's on this computer without copying the file. The video will go through the network cable and I can watch it here. I'll access the file through the network. The video is opening here. It takes a little longer than if it were directly on the computer. This is our test video. It will always be stored on computer A, on the hard drive of computer A. But after we connect the network, you can also access it from computer B. So, at this moment, maybe you're already watching me from computer B, but the file is stored on A. It's going through the network cable to get here. So, in this really simple way, I've already created a network between the two computers. And now we can start to understand what the internet means, which comes from the word internetwork. Network means connections, so internetwork means interconnections. Here's an example. I have two computers connected by a single cable, but we could start to expand this thing, connect other computers that are far away that are mine. And that's it. That's the internet. Several computers connected with you, accessing files that aren't on your computer. But let's think about this very video you're watching. The one you clicked to see me. It's on some server, on some computer, and it's reaching you through a path more or less like this. But there's a problem, right? For your computer to have access to a bunch of servers, it would need a cable to connect you to each server, and that won't work very well, right? To solve this problem, there are places where you connect your computer, and it connects to a bunch of other computers. That's one of the roles of data centers. So, besides storing information, they also connect you to other places. Hubs, like an adapter, where several connections come in and one goes out to you. But, in the case of this video, your internet provider probably connects you to a data center, which is the one that will connect you to the server where the files are stored. Or it might even connect you to another data center, which is the one that connects you to the server where the files are stored. And here's a detail: this video probably has copies on several servers around the world, but that's the basic way it works. So, in the end, when we talk about internet speed, we're talking about the time it takes for information to travel along these paths. You know, when you hit play on a video and that little circle keeps spinning, that's the information being transferred, being transported over the internet to reach you. That's called latency. It's the time it takes for information to leave a server and reach a computer. Lower latency improves the viewing experience by getting content to the viewer faster. As you might have guessed, network connectivity is crucial for a data center to function well. This is where the internet provider's connections arrive, and several others leave, connecting this data center to servers in various places, inside and outside Brazil. Some connections don't go through the open routes of the public internet. They follow private, direct, secure, and much faster paths. Equinix buys fiber optic routes that only it can use. Most connections are made this way, but they can also happen over the internet via satellite. Having more data centers can shorten the distance and reduce latency. And Equinix has more than 270 spread around the world. But the secret is also knowing where they are and what connections they make. So, it's important to study which services are most accessed by users and which are the shortest routes. And then, we can really optimize this whole flow of information. And, as I mentioned about redundancy, the connections here are always duplicated. So, the providers we hire to have internet at home always arrive here via two separate paths. If one fails, the other still works. You may have noticed that a cell phone or a laptop gets hotter depending on what you ask it to do, like running a game or watching a video, because that puts more demand on the processor. Imagine that in a data center, with a bunch of computers working 24 hours a day, they need air conditioning. Otherwise, they'll get damaged by the heat. Now, I'm at SB6, which is the new Equinix data center in Brazil. It's already in the final stages of construction, but there aren't any clients installed here yet. It's next to SP3 on this Equinix campus. There's also SP5, SP7 under construction, and still enough space for 2 more data centers. This corridor I'm walking through, they call it the cool spine here. which is the backbone of industrial cooling. It's kind of like I'm inside that part of the air conditioner that's up there on the wall of your house or office. This entire wall is for air heat exchange, like a giant radiator. Here on the roof are the condensers, that part of the air conditioning unit that stays outside your house. But there's a difference. Besides them being much bigger, here they cool water that goes down to the data center, and it's the water that cools the air. This water isn't thrown away. It keeps circulating inside the system all the time. In the data centers, there was an energy efficiency calculation that compares how much is spent to power the equipment with how much is spent on cooling and lighting. This calculation can't be unbalanced to either side. So the system is designed to cool, but it can't cool too much either, otherwise it wastes energy. Here, we can really notice that. In the external hallway, the temperature is actually a bit high. But if I open this door, it changes completely in here. Where the machines are, it's cool, because the chilled air is coming from the floor. Everything is designed to make the most of the cooling. I'll admit that I thought everything would be cold when I entered the data center, but it's only near the machines that this happens. And another thing they do here is that when it's cold outside, they bring the air in, just filtering it first to use less energy.
We have initiatives in Paris and other countries, but Paris became most famous due to the Olympics. Ultimately, it's simple. We take the heat produced by the servers, connect the data center to the city's network, and make that heat reach homes, hospitals, and shopping centers. In Paris, it eventually reached the Olympic Park and the swimming pools, so we had that. The case where we ended up heating the Paris Olympics in the swimming pool of the Paris Olympics became very famous. But most importantly, Iber, even after the Olympics, we continue heating nearby houses, now over 1,000, using just this data center.
There's also a concern about water usage. At SP6, machines are expected to use almost no water except for human consumption. The climate control infrastructure we saw is even more crucial if we think in artificial intelligence. When I asked ChatGPT to create an image of me in Hawaii, surrounded by kittens in traditional clothes, that's an example of artificial intelligence. Some computer, somewhere in the world, is heating up to do that. The machine must work harder, since it's not just searching or accessing a database. It has to perform many calculations. In other words, for computers with artificial intelligence, cooling is even more important. And for that, electricity can't be missing, it has to be constant, ELD. So I'm here in the power room of the data center where they receive electricity from outside, process it, and send it to the equipment. The power can have frequency or voltage fluctuations, but they make sure it reaches the equipment without any interference, ELD. The idea is to have no variation in frequency or voltage at all. It's like the power strip you have at home, only much bigger. The goal is to prevent burnout, crashes, and data loss. The power comes from the street's electrical grid. But if there's an outage, the batteries kick in immediately to supply energy. We usually call this an uninterruptible power supply, but that's just one of the dozens of battery rooms they have here. So this can support thousands of servers. The battery is important to keep the machines running when the power goes out. But right after that, it passes the baton. It transitions to these generators. Here, look at this. This one has 24 cylinders. They can keep the data center running for more than 30 hours without needing to refuel. If I pull this wire here, do you think your internet over there will go down? No. It won't fail. I told you everything here is redundant. The building is designed to ensure that, acting like a mirror, each side reflects the other. If a meteorite hits one side, the other ensures connections remain active. Equinix has 492,000 active interconnections worldwide. Just in Latin America, they provide transparency and transmit data at 15 terabits per second during peak hours. It's as if 3 million people were watching YouTube in high resolution at the same time. Sometimes you may forget that technology requires a physical structure, uses energy, and occupies space. Today, you become the information that moves across the internet. If we were to run through these cables, we would pass through here several times a day, every day. So now you know the path very well and understand the importance of data centers, so that information reaches you in seconds, or better yet, in milliseconds.